All right, good morning. Welcome back to Trigonometry here. Here we're sort of lecture two, so we're going to talk about three things today. We're going to talk about something called coterminal angles. Okay, and then we're going to do some problems. Then we will talk about arc length, and again, we're going to go do some problems. And then finally, we're going to talk about sector area. Again, we'll do a problem. All right, so coterminal angles, that's the first little bit that we're going to talk about. It is kind of like it's kind of like a clock. So if I asked you what time will it be in 12 hours, like say for example it's 1 p.m. right now, and we go ahead and we say, okay, what time will it be in 12 hours? You're like, well, clearly it's going to be 1 p.m. So we wouldn't say, well, it's 1300 hours, right? You might if you're in the military, and then say, okay, well, let me go ahead and add 12 to that and say, okay, well, that's going to be 2500. And then we need to go back in time and say, okay, well, it's minus the 24, we go back to 1 a.m. Okay, so you wouldn't go through that arithmetic. Similarly, if I said, okay, it's 1300 hours right now, what time will it be in 2400 hours or 24? Yeah, 24 hours. You wouldn't go through and say, well, let me add 24 to all of this and figure out what's going on. We wouldn't do this. You would just say, oh, it's going to be this. Excuse me, my kitty is, see, she's adorable. Okay. She wanted to know what's going on, but she wanted to help. But yeah, you wouldn't add that up and then say it's going to be 1 p.m. You wouldn't bother going through this. You would just look at it and say, okay, it's going to be 1 p.m. 1 p.m. tomorrow. Okay, so that's kind of what coterminal angles are. So the idea of a coterminal angle is um, like say we start off with like a 45 degrees and we want a coterminal angle. Like it's good that we have this 45 degrees, but we could also say, well, what happens if we go around one more time? Right. And that coterminal angle will be 45 plus 360. Let's go ahead and make that happen. So we have a 5, a 0, and a 4. So we'd say 45 degrees and 405 degrees are the same angle. It's just one rotation differently. Kind of like asking you, like, what time will it be in 24 hours? Okay. So we could go around forwards. We could also go around backwards, right? We use red for the negative. So we could say we have 45 degrees. We could also go around this way and get our angle that way. Okay. And both are okay. It just kind of depends on what you want or what you're trying to show here. But a lot of times in our problems, we will ask you for a positive coterminal angle and a negative coterminal angle. Okay. We could ask you for more. I mean, there's nothing, we went around once. I could go around many times, and we just keep adding 360 degrees to all of what's going on here. And we could just go around multiple times for all of this stuff in order to figure out what our angle is going to be. Okay, so if we do a couple of different problems, let's say, okay, let's look at if we have 75 degrees, and we want two coterminal angles to 75 degrees. So we're going to say we're going to add 360 to this. So we end up with a 5, a 13. So we say, okay, 435 degrees is coterminal. And then we're going to say 75 minus 360. And you'll forgive me, I have to do my subtractions this way. Okay, so we're going to end up with doing this. So we could say, okay, that's going to be a 2 with a we're going to be a 15 here and then a 5. So we're going to have a 5. 15 minus 7 is going to be 8. And then we end up with, we have a 2, but we know it's negative. So negative 285 degrees or 437, 35 degrees. Those are both coterminal to 75 degrees. All right. And that's pretty much what you do with this stuff. You either add 360, and again, just because I asked for one, like we could ask for seven. We could just keep adding 360s until we have a whole list of coterminal angles, which would be fine. But I probably would never ask you to generate a list of coterminal angles. Okay, it just isn't a thing that we tend to have people do. Okay, what happens if it's in radians and it's not in degrees? So let me give you another example. We have 5 pi over 6. And I would like two coterminal angles, one positive, one negative, to the angle 5 pi over 6. First off, let's go ahead and figure out what 5 pi over 6 is. Right? Here's 1 pi over 6. Here's 2 pi over 6. Right? That would also be pi over 3 if you wanted to reduce. We have 3 pi over 6. Again, you could reduce and get pi over 2, remembering that 90 degrees and pi over 2 are two ways of saying that angle. We have 4 pi over 6, and again, we could reduce. And then here we have 5 pi over 6, okay? So we know where 5 pi over 6 is. It's going to be over here somewhere, all right? In order to get angles that are coterminal, 5 pi over 6, we do the same thing. We add a rotation. Well, in radians, that rotation is 2 pi. Now, Sister Mary Agony, that's my fifth grade math teacher, she would be very upset if I just wrote down 5 pi over 6 plus 2 pi and then left it that way. She'd not be happy. We have to go ahead and combine these fractions. We're going to say 5 pi over 6 plus, and there's two tricks in math. Okay, I'm going to get common denominators here. The two tricks in math. One of them is to add 0, and the other one is to multiply by 1. We're multiplying by 1 here. We're just getting a common denominator. So instead of saying 2 pi, I'm going to say this is going to be 12 pi over 6. And then we're going to go ahead and add these. We end up with 17 pi over 6. Now, Sister Mary is not quite so concerned about improper fractions because she's taking calculus. And in calculus, we don't really care about improper fractions. So that's okay. Just leave it as 17 pi over 6 and be happy with that. We could also say 5 pi over 6 minus 2 pi. And again, we're going to go through the same little thing here. We have 5 pi over 6 minus 12 pi over 6. 5 minus 12 is going to give us negative 7 pi over 6, and that would be coterminal. So again, we could count this around, right? Looking at what's going to happen here. We'll go ahead and we'll say it this way. So we have negative 1 pi over 6, negative 2 pi, negative 3 pi over 6. That would be negative 90 degrees, right? To be straight down. So this is negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, right? And then finally, we have negative 6 pi over 6, which you say, well, isn't it the same as 6 pi over 6? Like, it sure is. It's just one way is going around in one direction, the other way is going around the other direction. But we still end up in this spot opposite from the zero, from the x-axis. And then finally, we end up with 7 pi, negative 7 pi over 6. Okay, and that would be our angle. So looking at like where's 5 pi over 6 and then where's negative 7 pi over 6, you can see that these have the same terminal side. They are coterminal angles, right? So that's the idea of coterminal angles, and that's how you generate them. Is you just add one rotation or subtract one rotation, whether that be in degrees or in radians, it doesn't really matter. You just have to know which unit you're working with. All right, and that's pretty much what we do with this stuff. All right, so let's see here. We want to go to the next little thing here. So the first problem. Oh, we don't want to quite go that yet. We want to talk about, that's coterminal angles. We want to talk about arc length. Okay, so arc length is S is equal to R theta. That's the formula we have for arc length. Okay, my arc length is going to be a length, right? The radius, that's the R, is also going to be a length. If we go ahead and say theta is equal to S over R, remember arc length is in lengths, radius is in lengths, the angle, the lengths cancel, the angle is a unitless number, which is why we do not write down a unit for our radians. Okay, it's a unitless number. All right, that's why you're going to see it that way. Degrees is a little bit different, but the way that radians are defined is we have the arc of the circle divided by the radius of that circle. That's the angle that we talk about. Okay, so that's why you never see units when it comes to the radians. We just don't put them in there. But this is a fairly straightforward three-variable equation. You've dealt with lots of three-variable equations, right? D equals RT, F equals MA, V equals IR for the people who study electronics. You know, there's lots of three-variable equations that we got to deal with. This is yet another one. We have S is equal to R theta, okay? Provided theta is in radians, okay? That's really important. Theta has to be in radians for this thing to work, okay? Not degrees. That's not going to help us. We need to convert everything to radians. So let's go ahead and look at a couple of problems here, okay? So we have a Ferris wheel of radius of 12 meters, travels through an angle of 150 degrees. how far did a person sitting on the edge of the Ferris wheel travel? Okay, so we're going to say, well, the first thing we have to do is we have 150 degrees, and you have to remember that 360 degrees was equal to 2 pi. So 1 degree is equal to 2 pi over 360. We'll reduce and we'll say that 1 degree is equal to pi over 180. 150 degrees should mean that we have 150 times pi over 180. We're going to convert this to radians. Okay, we'll put down the 180 degrees right here so the degrees cancel. Okay, we'll be just left with that unitless number there. Let's go ahead and say 150. That's really equal to 3 times 5 times 10, 3 times 50. And then 180 is going to be 3 times 6 times 10 times my pi, right? That's a fancy way to write 180 is 3 times 6 times 10. And we're just going to cancel some common terms here. So the 3's will cancel, the 10's will cancel, and we'll end up with a 5 pi over 6 as far as our angle goes. So now you know that 150 degrees is 5 pi over 6. In order to figure out how far this person went, we're going to say S is equal to R theta. So S is equal to, let's go ahead and look at, we have a radius of 12 meters times my angle of 5 pi over 6. And we'll go ahead and say, well, 12 is really 2 times 6 times 5 pi over 6. We'll go ahead and just drop out the common terms there. And we'll end up with, this is a total of 10 pi meters. Okay. Usually in your books, they're going to tell you if they want a decimal answer, they will tell you report your answer to 3 decimal places, to 2 decimal places, to whatever they want. But if they don't tell us, they usually want the exact value, and we'll let the person who is responsible for figuring out, what the stresses on a human body are going to be for this Ferris wheel to decide what decimal places they are going to want with this thing. Okay, so if you're building the Ferris wheel and you're responsible for the safety, you're going to have your own idea about like how many decimal places are needed in order to figure this thing out. Okay, but if they don't specify, we're going to try to go with exact values as much as we can. That's going to be 10 pi meters. Whoever the engineer involved is, which will be you someday, will go ahead and calculate this out to a decimal place that they seem relevant to the problem. Okay, so we'll go ahead and we'll look at the next problem. Okay, so that's kind of pretty much how you do those. Okay. Problem number 2. Okay, we have a tip of a clock's hand is 9 inches. That should be it. Okay, is 9 inches from the center of the center of the clock. How far does the clock travel in 20 minutes? Well, the first thing we're going to do is we're going to draw a clock. I had a stroke a few years ago, so this is not my first time drawing a clock, although it's a little bit better than we did before. Let me just go ahead and say, let me just draw a circle first. Okay. Okay, so we've got our 12, 1, 2, 3, 4, 5, 6 at the straight bottom there, 7, 8, 9, 10, 11, and 12. You may not believe it, but this is a lot better than when I was first asked to draw a clock after I had my stroke. But we need to know how far is 20 minutes. Okay. Well, actually, the first thing I want to do is figure out how much of an angle is between any 2 consecutive numbers. So we want to go with one full rotation, and we're going to divide this into 12 different spots because that'll be the 2 different numbers. And this will give me, we have pi over 6 as an angle between any 2 consecutive numbers. Well, let's go with 20 minutes, right? We have 20 minutes. We have 5, 10, 15, 20. We have, right? We have 4 numbers that we're going to pass through. So we're going to say 4 times pi over 6 and get our whole angle here. That's going to give me 2 pi over 3 as my angle. In order to go ahead and figure out the arc length, what they're asking for, like how far did the tip of the clock face move, we're going to say S is equal to our theta. This is going to be 9 inches times our 2 pi over 3. So this is 3 times 3 times 2 pi over 3. We'll cancel some stuff. And we'll say that we have 3 times 2 is going to be 6 pi inches. And again, at this point in time, unless the problem asked me for a specific decimal uh, tolerance, I would just leave it at 6 pi inches and let whoever wanted to figure out anything more go figure out how many decimal places they really wanted. Okay, and that's pretty much what we do with all of that. Okay, let's see, problem number 3. This one I forgot to write down. I'm going to say this is also going to be a report your answer to 2 decimal places. Okay, okay. So we're going to go figure that out. So this one, they actually do want a decimal approximation. So we're going to go ahead and go through the whole thing. So the wheel rotates through 420 degrees. At first thing you're going to say is, wait a minute, that's more than one rotation. I'm like, yeah, it sure is. And we don't really have to care about that because arc length doesn't say it has to be an angle between 0 and 360 or 0 and 2 pi. It just says we need an angle. It could be more than one rotation. That's fine. Okay. So the first thing we're going to do is we're going to convert our 420 to that 420 degrees into radians. So the first thing we're going to do, convert to radians. Okay. The second thing we're going to do is calculate our arc length. Okay. And then the third thing is we're going to provide a decimal approximation. Okay. So the first thing we have to do is we have to say 420 degrees times pi over 180 degrees. We just did that. So you should remember pi over 180. And again, if you don't remember, that's okay. We can just go back and say 360 degrees is equal to 2 pi and just kind of redetermine this conversion factor. Okay. But what do we have here? We have 6 times 7 times 10. That's a fancy way to write down 420 times pi. And then we're going to say we have to divide by 180. And we'll say this is 6 times 3 times 10. That's a fancy way to write 180. So the 6's will cancel, the 10's will cancel, and we end up with 7 pi over 3 as my angle. All right. So that's what we're doing with this. So now we want to go ahead and figure out our arc length. So S is equal to R theta. Our R is 0.35 meters. And we're going to multiply this by 7 pi over 3. I'm going to go ahead and get out my calculator here. Let's see if we can do this. And then we'll go ahead and write this thing down. So we're going to have 0.35 times 7 divided by 3. Okay, equals, and I'll just do that for a moment. And then we'll say, by the way, times pi. So second function pi here. And that'll give me we'll say the 2 decimal places. So that's going to be 2.565, 2.57. And I believe we are in meters. Okay. And that's pretty much how you go through and do that. All right, let's see if we have one more here. Okay. Oh, sector area. Let's look at the sector area for the formula for sector area. So first thing we're going to do is we're going to remember, like, what is the area of a circle? And that was pi r squared. And that was the whole area of a circle here. Okay. I would love to have an area of a circle, area of a sector that had to deal with r and thetas in it, because that's kind of what I want. This goes all the way around. We don't seem like it has a theta in here, but it kind of does. And I know that because usually, not always, but usually in radians, your angles have pi's attached to them. Okay. So a fancy way to do this might say we need a whole way around a circle is 2 pi. How would I get 1 pi out of it? I'm going to multiply that by 1/2, right? And that'll cancel the 2's, and I'll end up with 2 pi r squared, right? As far as, or 1/2 2 pi r squared as my area of a circle. That is exactly the area of a sector. So area of a sector, okay, is equal to 1/2 theta instead of 2 pi. We're going to say theta because that's the angle we're going to go through, r squared. 1/2 theta r squared is my area of a sector. Okay, again, provided theta is in radians. Okay, this must be in radians, otherwise this whole formula doesn't work. All right, and that's kind of what we're doing with this thing. All right, we have a little bit of a problem. We have a garden sprinkler sprays an area, sprays water in a circular sector of radius 8 meters at an angle of 225 degrees. What is the area of the garden and the water? What area of the garden is the water sprinkler sprinkling? Okay, what's our area for what's our coverage here? So we're going to say, okay, we need area equals 1/2 theta r squared, but theta has to be in radians. So we have 225 degrees here, and we're going to say we have to multiply this by pi over 180, and then we have to figure out what's going to happen here. So let's see here. This is 15 times 15. I know that. Okay. Times pi, and we're going to say this is going to be 3 times 6 times 10. Let's go ahead and factor out some stuff. So let's see. This is 3 times 5. That's 115 times, we'll say another 3 times 5. Okay, times pi. And then we have 3 times 6, but instead of 6, I'm going to say 3 times 2 times 5 times 2 for 10. Okay, so 10 is really 5 times 2. 6 is really 3 times 2. And I do it this way because I want to cancel some stuff out. So I have some 3s I could cancel, some 5s I could cancel. Here's another 3 I could cancel. And it looks like we're getting, what do we have left here? We have 5 pi on the top over, it looks like 4 on the bottom, 5 pi over 4. So my theta, 5 pi over 4. All right, that's my theta. My area is going to be 1/2 theta pi over 5 pi over 4. Okay, times, and then what is my r squared here is 8 times 8, so times 64. So times 8 times 8, that's my r squared here. Okay, 2 times 4 is 8, so we can cancel out some stuff with some 8s. And we have 5 pi times 8, so this is going to be 40 pi. I think it's square meters. Yep. So we have meters squared here, and that's my area. If we were asked for a decimal approximation, I don't think we were in this case, but this will be a lot easier to type this in. You could have typed it in at the beginning. Like I'm not, when you guys take your exams, when you take your quizzes, I'm not taking your calculators away from you. You're allowed to use your calculators for as much as you want to use them. So my goal here is to be proficient with the calculator. Um, Usually I'm standing up at a whiteboard or a chalkboard, so I don't usually have a calculator at the hand. So that's why I go through all of this stuff with reducing and making sure it's easier. The other reason why I do this is because I watch students go through the calculators and they go through it not as precise as they should. And if there's a whole bunch of numbers that people have to put into the calculator, your chance of human error goes way up. So I see this mostly with my statistics students, but nobody is immune from not using the right parentheses, not using the right operation. It's like typing in a 6 instead of a 9, whatever. So you're allowed to use the calculator for as much as you want, but like I said, I typically am standing at the board, so I don't have the calculator at hand, so I don't like to use it quite so much. Okay, that's why I go through all the factoring and making sure that the work is a little bit easier for me to type in. But if we wanted to do this to 2 decimal places, we'd say this is 125.66. So 125.66 to 2 decimal places, right? We go through and say, yeah, the 3, so we don't go through that. So 1.26 meters squared, and that would be our final answer for that. Okay, and I believe that is all the problems that I have for arc length and for sector area and for coterminal angles. So with that, you have well more than enough to finish off your first set of your homework. So very, very good and go do that. And we will see you here on the next videos. Thank you very much for watching, and we will see you in the next video.